having me. Thank you, Tall Building Council, for letting me present our building Gaia, located in Quito, Ecuador. Let's start from the beginning, our team. Our team is a collaboration between Oliver Schwarzkopf, the developers and the interior architects, and us, Leppanen and Anker, who are this small design architecture firm, proud to be female-driven, with 80% of the workforce being female. Where is Gaia? Gaia is located in South America, in the country of Ecuador, in the city of Quito, in the Ecuadorian line. It's actually located in 93,000 square feet above sea level, but it actually has a privileged weather condition. The city of Quito has natural boundaries. It's actually 30 kilometers long and 8 kilometers width. Gaia is located in the center-north part of the city. The city of Quito is going through a lot of different transitions right now. There's the new metro station, there's the removal of the airport towards the outskirts of the city, and this has created a new sensation for the city. It has allowed it to become more vertical and with new centralized nodes. Its unique location was our main source of inspiration. It's a dynamic place with contextual energy. This site is in the heart of the city. It's located to the most emblematic park of the city, next to the biggest shopping center, and across to governmental office spaces. The corner condition. The site has a special corner condition that joins between a lot of green space, one side the park, and the other side the natural surroundings. Natural surroundings. This is the active volcano Pichincha, which starts creeping into our building, and that became really important for us to frame it, to expose it, and to contextualize in our design. We took into consideration the massing. Our massing started with a footprint. The footprint became a volume, and the volume started being considered a sculpture mass. We started taking strategic corners to create double and triple high spaces to frame those surrounding areas. The extraction of these corners tried to maintain the fluidity of the design. The corners became key design strategies for the building. It allowed to look through the design. This corner's extraction framed the building, but also framed the program within the building. In the first floor, we had the courtyard, the way that we invited the public to be part of it, being commercial space. The next 4 stories will be office spaces and the rest residential, making this building the first true mixed-use building in Ecuador. The repetition of the floor plates, using inside and outside spaces, and creating sustainability for construction. Now, this is something that the Israeli presenter will be jealous. Quito has a privileged weather, so therefore we don't need heating or cooling systems. But the orientation of the building became fundamental, and the cross ventilation, and the extends cantilevers to create heat reduction within the building. Therefore, it allowed us to have the facade have floor-to-ceiling glass to make the space inside feel more generous. This was our design intention, and we needed to find something that will help us translate our intentions in material. Parametric model system. We use the parametric software to coordinate our building. This was the first attempt done in Ecuador, but it worked seamlessly in the coordination with the fabrication, the builder, and the architect. It was a precise model for a really low-tech precision process. It was a really sophisticated tool used in a really basic way. Material research. We were inspired by the stucco colonial Spanish constructions in the city, the sun reflection, the local environment. We were mesmerized at the change of color of the facades in these buildings, and we wanted to take those sensations in a more contemporary and sophisticated way. The existing construction methods in Ecuador. 99% of the buildings in Ecuador are pretty much the same. They're concrete block fill with stucco cladding, and sometimes, if you're lucky, with fake brick as a cladding or stone. Alucobon became a little bit in fashion, but we didn't want to use that. So we have materials limitations. Why GFRC? Well, GFRC material checked all our boxes. It was a material that will be moldable, that will allow us to make folds, to be bent, to create creases, and to do double curvature. For our experience in the United States, we knew this was a possibility, and this was an opportunity to create an innovation in construction in Ecuador. The boxes, the cost, adapt to existing construction system, formal flexibility, high level of detail, durability, quality, installation. The panels efficiencies. Since we worked in a sophisticated model, we were able to understand how many panels we needed to have to create our form. It took us to 360 models. But we knew that for efficiency and cost efficiency, that was going to be impossible. So we were able to re-engineer and revalue and respect our design and create 30 molds. Molds that were able to be fabricated in a really simple and low-tech way. And we analyzed as well the size of the moldings. And in this case, we did it at 4 meters by 2 meters that will be easily applicable to the facade and transported to outside. So we also created a control environment. So we wanted the quality of these molds to be specific to our needs. And it was transported and installed really simply by crane. Well, now the panels were able to be touched in our facade. It was a joint venture between customary construction to an innovative construction. It worked like a puzzle. On site, the secondary skin, the panels, had steel substructure that was able to be bolted to the existing concrete slab, and then on site, it was able to be maneuverable and joined to make it a seamless connections around the building. It also allowed some spacing for seismic movement. This is a little bit of the different details that we created of the transitions between the panels and glass, the panels and overhangs. Details of the overhangs, drip edges, joints, balcony and integration, transitions of details, security, anchoring, alignment systems. Then we get to the rooftop. We wanted to invite and have a living elevated garden on top. We wanted to frame these views. We wanted to reconnect to this main idea of the building, to frame the nature, the urban spaces, and the nature. We wanted to have the structure of the building being invited into inside spaces of the building to create an element of surprise, could celebrate structure, to have a connection not only outside, but to the inside users. The benefits of this construction, it was an innovation not only for Ecuador, but also for the region. We created efficiencies, opportunity for new sculptural forms, sensations of lightness. The building is located in a really highly visible place in the city. We were not only taller than the surroundings, but we were modern, we were volumetric, we were formal. We created movement, we created shadows, we created lines, and we became an icon in the city. The success of this building was to push architecture fabrication in the context of the region. Relationship between fabricator and architect was smooth. It was successful because we were able to push our providers, our fabricators, not to attend something new in the market, but also to do something in a high level of execution. Everybody got tested, and the testing will allow future buildings to take additional challenges. It opened the vision for what architecture facades could be. Broaden a spectrum of design. Bringing international standards of construction to Ecuador and bringing Ecuadorian architecture to international eyes. Again, the connection and the views to nature and the importance of what is surrounding us.